Hello. In this video we're going to show how we can relate our generator circuit to a real life scenario, and that's going to be a car. So you can see here that we have our 4 cells wired in series, and they give a 6-volt output potentially. In a car you'd have a battery, and the standard car battery has a 12-volt output. So you can see here that our circuit scenario offers perhaps half the voltage of a standard car battery. Next we have our switch, and that represents the ignition switch in a car. So when you get in, you use the ignition key, you turn it, and hopefully your engine will turn over and run. So you can see here we've got our motor, and that represents our engine in our car. We've got a pulley here driving our belt, and in a car that would be the camshaft pulley. Now we've got a very simple setup here. In an engine bay it would be much more complex. You'd see that we'd have a belt, and then there would be various different tensioners, and then that belt would run around various different pulleys on various different components. So it would potentially run the water pump in the engine, and the water pump's very important because that pumps coolant around the engine block as the engine's running, making sure that it remains cool. You might have air conditioning, so it might run an air conditioning compressor. But our generator is going to represent the alternator, and the alternator is a very potent part of the engine setup. So when you start a car, you use the battery to turn the engine over, and you'll also be running lots of electrical circuits in the car while you're driving along. Maybe the windscreen wipers, the headlights, you'll be using the radio, the sat-nav system, maybe using electric windows and sunroofs. So all the time that's causing a drain on the battery. So by running an alternator, you'll be able to create an electrical output that then charges your battery and make sure that while you're driving along using all these things, that your battery doesn't go flat. And that means that when you come to stop your car, it will allow you to start it again because it's been charged by the alternator. So let's connect our circuit up. Connect the positive terminal from our battery to the red positive terminal of what would be our engine, and then we're going to connect the lead from the negative terminal of our battery to terminal on what would be our ignition switch. Then we're going to connect the lead from the terminal of the ignition switch to the negative terminal of what would be our engine. So if I start our engine, turn the ignition switch here, you can see that our engine is running. You can see the belt turning, and that's driving the pulley on our alternator. Now you can see from the previous activities that we've done, if we vary the size of our different pulleys, we can vary the ratios here, and that means that we can maximize the voltage output from our alternator. So let's measure the output, and we're going to do that using a multimeter. So here's our multimeter. You can see that we have a volts DC scale here, and we're going to use the 20 volt setting, and you can see that we have 3 sockets, one marked COM, and we always put a lead into COM when we're connecting our multimeter to a circuit, and the other socket we're going to use is the volts, ohms and milliamps socket. let's switch our engine off. So we're going to connect our multimeter or voltmeter in parallel to our engine. So I'm going to connect a lead from the volts, ohms and milliamp socket to the red positive terminal of our engine, and then I'm going to connect a lead from the COM socket of our multimeter to the black negative terminal of our engine. We're also going to measure the voltage output from our alternator. So you can see here we're going to connect our leads from our alternator to our multimeter. So if I connect a lead to the red positive terminal of our alternator to the volts, ohms and milliamp socket on our multimeter, and then I'm going to connect a lead from the black negative terminal of our alternator to the COM socket on our multimeter. So we're going to measure the voltage. So we're going to turn our multimeters to 20 volts DC. And now let's start our engine. You can vary the tension. And here you can see that I have now just about 4.6 volts going to our motor, but my output from my alternator is currently 5.37 volts. So we've got a higher voltage output from our alternator by using these different ratios of pulleys. Okay, let's switch our engine off. We've shown that we've got a good voltage output from our alternator, but now we can add another component. So first of all, I'm just going to disconnect our multimeter here, and I'm going to switch it off. So our next component is going to be a capacitor. You can see the circuit symbol here, and you can see that we have a black negative terminal and a red positive terminal. When you use a capacitor in a circuit, it's really important that you wire it in the correct way, otherwise you can cause damage to the capacitor. So we're going to use our capacitor to represent the charge that would be built up to the battery from our alternator. So first of all, we need to wire our capacitor in parallel, to our alternator. So if I connect a lead from the black negative terminal of our alternator to the black negative terminal of our capacitor, and then a lead from our red positive terminal on our alternator to the red positive terminal on our capacitor, now they're wired in parallel. So next I need to connect the multimeter to our capacitor so that we can register the charge. So I'm going to connect the lead from the COM socket to the black negative terminal of our capacitor, and a lead from the volts, ohms and milliamp socket of our multimeter to the red positive terminal of our capacitor. Okay, so let's turn our multimeters back onto 20 volts DC, and let's start our engine. Okay, so you can see that we have our voltage across our engine, and now you can see that the charge is increasing. We have 1.4 volts charge in our capacitor. So as our engine is running, it's turning the pulley on our alternator, and by driving the alternator, then that has an output voltage. We'll be able to use that to charge our capacitor, which would be in theory our batteries. So as we're driving along, the alternator is working, it's creating a voltage output that then is charging our battery to make sure that our battery doesn't go flat. So we've been able to show that using our generator circuit.